I'm your host, Swapnil Bhartiya, and welcome to Let's Talk. And today we are going to talk about Intel's oneAPI rendering toolkit. And to talk about it, we have with us Jim Jeffers, Senior Principal Engineer and Senior Director of Advanced Rendering and Visualization at Intel. Can you talk a bit about the oneAPI initiative from a broader perspective because it's an industry-wide initiative?
At a high level, the reason we're doing this, or we're creating an industry-wide initiative. So it's Intel hopefully being a leader with an open source focus. We'll be talking about open source a little bit more, but it's an open source, open API. That's why it's called oneAPI. Component libraries, components, and a use model that crosses all platforms from all vendors, okay, is the goal. And then is what we call cross architecture, which means our CPUs, our GPUs, not only ours, the industry's central processing units, graphics processing units, FPGAs. There are now network processing units. And the idea is to have an initiative. It's not an overnight thing. We've been working on it for a couple of years already, but the movement is single code base runs everywhere. That's the simple thing. And then secondly, fully open source. The compilers are open source. There's a compiler called Data Parallel C++, which allows more parallelism capabilities, but extracted from a GPU, extracted from a FPGA, utilize your CPU, all with one tool chain and development tool chain and libraries that cross architectures. Now we need our vendor partners, AMD, NVIDIA, the many partners out there to join up, and that's not going to be easy because it's an industry, but or an initiative that feels like Intel's driving it, but we really truly mean openness. And one quick example is Apple's M1 ARM-based devices run almost all of Rendering Toolkit's libraries. That already happens. So we are deeply into enabling Apple and others who have the products to ensure that the marketplace isn't left behind. So that's the initiative: cross-vendor, cross-architecture, open tools and elements. And we are applying that every day to our own products. And then we're supportive of others joining in. Make the world easier for developers. It's the biggest complaint that we see is I have to detect whether I have your vendor's product on there and then write different code. We're trying to solve that problem.
Jim, can you tell us a bit about the oneAPI rendering toolkit?
It's a collection of rendering and compute for rendering optimized libraries. They have continued to grow over the years. The most well-known one that has been in the market close to 10 years or more is called the Intel Embry Ray Tracing Kernel Library. That's sort of the heart or the beginning of a collection of libraries with the goal and the overwhelming majority of the libraries have some relationship to ray tracing, or what's called physically based rendering, where we use the physics of light and mechanisms around that to take a virtual 3D world and allow it to be rendered up to photorealistically. So the oneAPI rendering toolkit is more than just Embry. Embry's the most well-known. Embry won an Academy Award this past year because of its impact to the film industry. And Embry has always been an open source project. Everybody can see what Embry is. A detailed scientist or researcher graphics researcher can look at the code and see what we do. But the goal is optimized high-speed rendering with a wide array of features to deliver the highest fidelity. Other elements that have come to fruition with the tool is something that's really gotten a lot of pickup in the last couple of years. It's our AI-based denoiser that is called Open Image Denoise. Again, everything I'm going to talk about is a fully open source project. We do most of the code. We do accept contributions, but we're really trying to put the highest performing, highest quality set of components useful. So we use AI-based mechanisms to help filter out noise that is inherent in the earliest phases or through the phases of ray traced rendering. And this allows you to create a photoreal image, but sort of cut it off. If you want it to be truly photoreal and what we call 100% converged, depending on the 3D model, depending on how complex it is, you're talking hours before it can get rendered on CPUs or even GPUs. When you add this denoising filtering capability, when it's as high quality as Open Image Denoise, you actually just get to that solution much faster. Now, for a final movie, you still might want to wait, because the more you compute on a ray traced image, the closer it is to the physics of light and how your eyes receive it. Then finally, or not finally, additionally, Embry, which does geometric rendering, Open Image Denoise, which provides a denoising artificial intelligence or deep learning based denoising algorithm that really provides, it's actually the highest quality in the industry. We're going to be talking about that quality in, I guess, a blog that will hit right around when this hits. And then the next thing is what's called volumetric rendering. So Intel Open Volume Kernel Library, we tend to call it Open VKL, is hitting 1.0. It's been available in the market for well over a year, but we've worked with our partners to push it to the point that it's fully featured, ready to go, and we euphemistically call it the Embry for volume rendering. What is volume rendering? Volume rendering is effectively when you have a space of pixels or objects that are effectively on in a 3D cube, if you will, in some form or another. And it is heavily used in particular in, again, movies, but it's also used in scientific visualization. But in movies, explosions, right? Explosions aren't really geometric objects. They're fog, clouds, things like that you want to be realistic. Volume rendering is important for that. And volume rendering is really picking up across a wide variety of areas. So we have that product. And then we have a product that brings it all together in an easier use fashion than the individual ones. And that's called Osprey. And Osprey brings a rendering infrastructure that consumes as libraries Embry, Open Image Denoise, and Open Volume Kernel Library. And now you have a higher level API that a traditional graphics programmer can make sense of. You don't have to be a ray tracing expert to use it. So they're the four main libraries, and then there are a couple other components. One's called Osprey Studio, and the other's called Osprey Hydra, Osprey plugin for the Hydra API. And Hydra is this API defined by Pixar within an open source project called Universal Scene Description, which is also getting dramatic uptake in the industry because it allows interchange of the same format data from multiple studios in order to make a movie. And today's movies, even though it says Pixar on it, you probably have had 20 contributors to it. And so USD makes that easier to do that. So we support the industry in that way. And then finally, I just want to say the domains are actually quite wide that ray tracing is used in and that our products are used in. And we've broken them into 4 domains that touch various areas, but you could think of your in-between domain, and that works. And the 4 domains are film, studio, media, and entertainment. The other domain, scientific visualization, high performance computing, high scale visualizations. And then product design and architectural design, often called architectural engineering.
We have already witnessed transformations from black boxes and proprietary technologies to open source hardware and software in many industries like at telco. Energy sector is also going through the same transition and transformation. What kind of transformation is happening in the studios?
Particularly, let's say, in the film industry. And now we see it also, like you said, across other domains. But in the film industry, you're completely right. It was say somewhere between 5 and 10 years ago, everybody had their own renderer. Everybody did their own thing, all the way down to the metal. And that's actually was one of the visions and goals of Embry from an open source perspective. Was they weren't getting the performance out of the hardware, which is a very the processors. They spend a lot of money on processors to do 3D processing, to do the ray tracing and the other elements, so that you get Thanos looking like a real character, not some cartoon thing or that type of thing. So that's just continued to grow dramatically. And the appetite, the consumer's appetite for realism, even when things aren't real, but that realistic view is very high. So now you have a cost, you have 2 levels of cost involved. It boils down to, hey, we're a capitalist society. We need to reduce costs or increase revenues, right? And you want to do both. So for a movie studio, you got 2 things. You've got multiple things, but the 2 key things that we've seen have created this shift to open source are, for the things that everybody has to do that are cross-industry and don't really affect what we would call special sauce or the look and feel of a Pixar movie, like Pixar's goal or DreamWorks' goal. I don't want to keep doing Pixar. Illumination's goal. These are all customers of Embry and users of Embry. And they do have a goal to say, oh, that's an Illumination movie, that you don't actually have to see it. That's that's almost an ultimate goal. So that look is their special sauce. But they want to put out more movies per year. They want to put them out at a lower cost. So when it comes to the lowest level access to the computing hardware, Intel and some of our competitors know their hardware way better and can make it shine much faster when you buy a new processor to take advantage of it. Our software is completely tuned to maximize that capability. So what we've done, what we've looked at with our open source and seen how it's used, and then there are other non-Intel versions of it too. The bottom line is things that can cross the industry where technology can be poured in. It's not like it's not low technology, it's high technology, but it doesn't provide a competitive differentiation. Open source is just exploding in those areas. And from the Intel perspective, it's our ability to take our products as they launch, because we're, Moore's Law and all that stuff, we're making things better, but it's complex. And my team are effectively ninja programmers who are the world's experts in ray tracing. So we provide these layers, and then things like the similar things for other software-only processing elements There's something called Open Color IO. Think about what that means. It's very simple. Color images in a movie better be able to look the same. So if you are having multiple people contributing to a movie, use Open Color IO to ensure that the end result color, which is a continuum in floating point space, is matches what you want. If you asked one person, one company to do a scene, and another company to do the scene, and the colors don't work, that's actually visible. So it's things like that. There's a thing called OpenVDB, which is a volume rendering, which we support in OpenVKL. Again, the industry is standardizing on open environments. And then you have the other notion in open source, which is both the benefit and the negative, which is they're usually a visionary or a small visionary who delivers the code, and then they start picking it up. If that's not curated, and managed as a community project, it could die and people could actually stop making movies. So I'll stop there. It's that type of thing. So it is important. It doesn't mean that the customized applications or the commercial applications aren't important. It's this mix of commercial and open source, and the foundational open source that is really exploding.
Let's talk a bit more about rendering. It's being used just beyond film industry. What other industries are leveraging it, and is oneAPI playing a role there?
Absolutely. So I'm going to pick automotive. We have a close partnership with Bentley Motors in the VW group, who is one of the spearheads of technology for VW. And there's a multi-level use case in automotive that a lot of people don't understand. The first one's pretty simple. Designing and then reflecting those designs to the marketplace in a way that people want to buy a car or know what car they're buying. Color, right? What color car do you want, right? We all love that. But the idea that it's, in order to give them the flexibility, they effectively need to make 3D movies of their cars to do commercials. Now, a lot of it's real, a lot of it's the environment, but a lot of it is manufacturing it in a way that's appealing but real and physically based. So they don't want to fool anybody, but they want to get efficiency. So automotive's there. The other twist that we're working on, which I think is super cool, is autonomous driving, a completely different rendering mechanism, validating that your car, it will successfully drive around the world. How do you do that? How do you prove that your AI is smart enough to do it? So there's a whole other project where we emulate the real world cameras, and then there's LiDAR and other things that need highly accurate, correct physical basis so that our future autonomous driving cars are actually ready to go. And I've heard in the past, or like 5 years ago from Tesla or whatever, in order to get their software to work, they would have to drive around to experience 150,000 miles worth of stuff. That's not economically feasible. But if a computer feeds it with real world data and you can randomize it so that the bird flies by while the kid's ball goes out and there's a big white truck in front of you, that is going to make it better. So there are two uses in automotive that I find very exciting, and we're actually actively involved in.
Let's go back to the film industry example. How are they leveraging Intel's rendering technologies and also oneAPI?
Not everybody knows this, but people in the industry do. Movie rendering is a high performance computing act. They have the equivalent of supercomputers, some in the cloud, some what we call on premises, at Pixar in California and at DreamWorks in LA and Hollywood. they have big things called render farms. It's called a farm for a reason because farms have big scope. And what we have done and what our a goal that is extended is our optimized software linked with their smart rendering and look and feel software, if you will, optimize the delivery of movies, making them, from the past, twice as fast to render or whatever. It is hours and hours of time to render a movie. So if we can add 10% performance improvement, that's a cost benefit. Interestingly, our code runs anywhere on a render farm if they're running 24/7. Embry or OpenVKL or OpenImage Denoise, when they're in there, that class of codes is running 50 to 80% of the time. The actual execution is in our code because that's where all the compute happens and everything. And again, that's a more generic thing so that when they get the answer from our code, they can do what's called shading or deliver the pixel that way. So one major use of oneAPI and one of the benefits is the flexibility that day after day, compute platform after compute platform, it just works. We make it so it just works, and all they have to do is integrate our latest codes. And so that's one of the major uses in visual effects, all that stuff has all this compute going on. We try to make that as fast as possible.
Jim, thank you so much for talking today, not only about oneAPI project, the toolkit, and all those exciting use cases, and also sharing that it just goes beyond film, automotive, you shared example. And I would love to have you back on the show, not only to talk about this initiative, but other projects that are there, which of course have some open source angles. So thank for your time today.
Oh, I loved it. It was great talking to you. I'm happy to come back when the time is right. And yeah, thanks to everybody listening, and we'll see you later.